Okay, hey, so here I am ready to show off the gray code adder in Minecraft. So, yeah, here we have, I just made this little diagram of counting up in gray code so um, it could help me with designing the, the adder, I guess. So I started working on this at, like, right when the stuff was assigned, and we hadn't really learned about registers yet, so I kind of had to makeshift design my own memory. Um, and it's not perfect, but it usually works. Now keep in mind I tested this maybe 39 seconds ago, and it was working then, so I hope it still works. So here you can see what the current here you can see what the current states are for each of the inputs. So since this is a 4-bit adder, we have, or 4-bit counter, I guess, we have D3, D3, or D3, D2, D1, D0. These torches down here show with the current settings what the next state will be when the clock cycles. Here is our switch, and we can switch from subtraction to addition. So since I guess we'll count up first just to show it. So we'll switch it to addition, and then this button right here like cycles the clock once. Let's do it. So obviously right now we have 0, 0, 0. So when we press this, it updates to 0, 0, 0, 1. You see, bada boom. And once all these are done changing, I'll do it again. Now it is a little bit slow because it's running on like 15, 16 tick delay, plus all the delay of the actual circuit. I'll show you what I mean in a second. But yeah. So, oh, I forgot. I was like, why is it not? There we go. 1, 1, 0, 0, 1, 1. So yeah. Now we go to the next state, and we got 0, 0, 1, 0. Right? There's the next state. So theoretically, the next state should be 0, 1, 1, 0. You see, that's what it says the next state's gonna be. So if I click this, go 0, 1, 1, 0, boom. And let's say I want to go backwards, and I want to subtract 1 and go back down to 0, 0, 1, 0. I can just flip this back to subtraction, wait for these to finish changing, and then I can click this, and it went back to 0, 0, 1, 0. And now I could keep counting up, but you get the general idea. I guess I'll keep showing it just so you can see it working. So 0, 1, 1, 0. Next state is 0, 1, 1, 1. Feel free to turn this part up in speed because I'm going to have to wait for this to update. It's going to be kind of slow. So I think if this is on YouTube, like I think it's going to be, you can probably click the gear at the bottom and speed this part up because it's going to be a little slow. But next state's going to be 0, 1, 0, 0. And the next state's going to be 1, 1, 0, 0. So the way this circuit, I guess I'll explain how the circuit's working while I'm testing it out. Just like with any other kind of flip-flop or adder, it takes the current state and inputs it in, and then it will feed the next state in once I cycle the clock, and it will use that to determine what the next state's going to be. So here we have 1, 1, 0, 1. Next state, yep, 1, 1, 1, 1. So it is a little... It looks a little wacky back there, and I'm sorry for that. I get a little sporadic when it comes to circuits in Minecraft, but luckily, Minecraft has a lot of verticality with it, so you can kind of just go up if you need to get more space. If it's 1, 0, 1, 0, so I should go to 1, 0, 1, 1. Yep. And yeah, okay, we only have 2 more states left. 1, 0, 0, 1. And I guess I will also show it counting backwards for a few stages. And 1, 0, 0, 0 should be next. And you see the final state, it's going to loop back to the beginning and go back to 0. Boom. And let's say I counted up one more time. And let's say I wanted to go backwards. Go back down to 0 again. Just give it a moment. There it is. And you see, I can go back down to 0. And then, hey, let's say I want to count all the way back up again. So if I subtract from 0, it's going to loop back up to the top at 15, which is 1, 0, 0, 0. And as you can see, it's just going to start counting backwards now. So there we go. So I'll give a quick show off. Oh, ignore that. But a quick show off of So here we have these are each of the registers holding the different values. That was me testing out a different type of register. I was trying to build like an actual flip-flop, but it doesn't really work very well. I don't really understand how these comparators work. So I just stuck with using repeaters, where as long as this one is running into the side, the current value is locked. So see, even if I took this off, it won't change, because as long as this is here, this value is locked. So if I turn this off, it won't actually change until I disable this one. And now that I turn it back on, it's locked at 0. So even if I put something here, it won't update until I turn this off to let it update again. Yeah. Oh, let's leave that there. So here's a bunch of the circuits. I think I probably showed this in the document, but here's like, they're all labeled. So this is C1 and not C0. And then over here we have C1, not C1 and C0, and S XOR C3. S is the switch from where 0 is subtraction and 1 is addition. Yeah, so here we have all the different circuit parts. And here are the separate outputs. Output 3, output 2, output 1, output 0. And what happens is they come down here and they cycle through. They go all the way across the bottom here. And then these are just ways for it to shoot back up into the top. So these little things right here are how you can see what the next value is going to be. So obviously right now I have it at 0001 on subtraction. So if we look at 0001, the next value should be 0000 for subtracting. And as you can see, that's what all these are off, so it's going to go into 000. So when I press this begin operation button, it disables the locks on all these for a moment to let them update, and then it re-enables them before they change to the next value, because we have like a bunch of delay on these flip-flops down here, or on these repeaters. So even when we disable the locks for a moment, they will re-enable by the time that the next value gets through. So yeah, that's the gray code adder in Minecraft.